Hello and welcome to Algebra 1, Lesson 44. In this video, we're going to learn about multiplying and dividing rational expressions. So in our last lesson, we started talking about rational expressions. We learned how to simplify rational expressions, and we learned how to find the restricted values for a rational expression. Now we're going to move on and start talking about some operations with rational expressions, and kind of the easiest ones to start with would be multiplication and division. Now, if you know how to multiply and divide fractions, the process is very, very similar. So let's start out by looking at 1/3 times 2/7. So what we want to do here is we want to multiply the numerator times the numerator. So 1 times 2 is 2. And we want to place this over the denominator times the denominator. So 3 times 7 is 21. So you get 2 over 21 there. Now remember, when you're working with fractions, you want the fraction to be simplified, or as they say, reduced to its lowest terms. Now, you can look at 2 and you can look at 21, and you can tell that there's nothing that's going to be common other than 1. And you can kind of start from over here. Remember, we're allowed to cross cancel. If I look at 1 and I look at 3, there's nothing in common there other than 1. If I look at 2 and I look at 7, nothing in common other than 1. And then I can look crossways, 1 and 7, 2 and 3, nothing in common there other than 1. So we would say that 2 over 21 is simplified, or again, reduced to its lowest terms. Now let's take a look at one where you can do some simplification. We have 5/8 times 4/15. So what I can do is I can multiply everything together first. 5 times 4 is 20 over 8 times 15, which is 120. But then I have to go through and simplify, so that doesn't make much sense. So for most people, what they'll do is they will cross cancel or cancel before they even start the multiplication process. So you look between numerator and denominator of each fraction first. Look between 5 and 8, there's nothing you can cancel. 4 and 15, nothing to cancel. Then I would look crossways. So I would look between 5 and 15. There's a common factor of 5. So 5 divided by 5 is 1. 15 divided by 5 is 3. And I'd look crossways again. Between 8 and 4, there's a common factor of 4. So divide this by 4, I get 1. Divide this by 4, I get 2. So now if I multiply, 1 times 1 is 1, over 2 times 3, that's 6. So I get 1/6 as the simplified form, or again, reduced to its lowest terms. And again, if you wanted to do 5 times 4 and get, 20 over 8 times 15, which is 120. So it's the same value, it just looks different. This is just unsimplified. 20 divided by 20 would give me 1. 120 divided by 20 would give me 6. So at the end of the day, you get 1/6, again, as the simplified form, or as they say, reduced to its lowest terms. All right, so what about division? So recall that to divide one fraction by another, you take the first fraction, or the fraction all the way on the left, and you leave that guy unchanged. Then you change your division to multiplication, and you're multiplying by the reciprocal of the second fraction. So if I take the reciprocal of 2/5, remember I take the denominator and I bring it and put it into the numerator. And I take the numerator and I put it down into the denominator. So I just interchange or flip the positions. Denominator becomes numerator, numerator becomes denominator. So that's how you take the reciprocal. Now once I've done that, all I do is I just multiply. So I can see that I can cancel a common factor of 2 between here and here. So I'll put this as a 1 and this is a 1. And now I just multiply 1 times 5, that's 5. Over 3 times 1, that's 3. So this is going to be 5/3. All right, so what about 7/9 divided by 14/15? So I take 7/9, that's my fraction all the way to the left. I leave that unchanged. And I multiply this guy by the reciprocal of this. 15 goes into the numerator. 14 comes down into the denominator. So that's how you take the reciprocal. Again, this goes up here, this goes down there. You interchange. So now what can I cancel? Between 7 and 14, I have a common factor of 7. So this will be 2 and this will be 1. Between 9 and 15, I have a common factor of 3. So this would be 3 and this would be 5. So now if I multiply here, 1 times 5 is 5. Over 3 times 2, that's 6. So I get 5/6 as my answer. All right, so hopefully you're familiar with multiplying and dividing fractions. If you're not at this point, you might want to go back into a pre-algebra lesson on multiplying and dividing fractions. Get up to speed on that, and then come back to this point in the video. So now let's start looking at some rational expressions. If I had something like 10/9 times 6 over 8x. So the only difference here is I have that one variable, which is x. Nothing else is really going to change here as far as the process. I'm still going to look to cross-cancel before I start my multiplication. So what are the common factors between 10 and 9? Can't really cancel anything there. Between 6 and 8, I can cancel a common factor of 2. So I can make this a 4x, and I can make this a 3. Now, I can do more canceling because I can cross-cancel between this 9 and this 3. So if I divide this by 3, I get 3. If I divide this by 3, I get 1. Then I can do some more cross-canceling because 10 is divisible by 2, and so is 4. 10 divided by 2 is 5. 4 divided by 2 is 2. So now I would just multiply. 5 times 1 is 5 over 3 times 2x. 3 times 2 is 6, and then x comes along for the ride. So we get 5 over 6x. All right, so that was pretty easy. Let's look at one that's a little bit more complicated. So we have 6r cubed minus 12r squared. This is over 7. And then we're multiplying by 7 over 4r squared minus 8r. So the trick to this is the first thing you want to do is you want to factor out the greatest common factor from every numerator and every denominator. Now, before I even do that, I notice that I can cancel this 7 with this 7, right? I can cross cancel. So this is a 1 and this is a 1. Now, if I kind of factor out the GCF here, in the numerator over here, it would be a 6r squared. So I can write 6r squared times the quantity. I would just have an r minus a 2. Now this is over 1, so I can write it over 1 or I can leave it as it is. It doesn't really matter. Because I have a numerator and denominator here, let me just write it over 1, kind of to make things consistent. So times, here I have a 1 over. The GCF here is 4r, so I'm going to write this as r minus 2 as well. Now, what else can I cancel? And there's two things I can cancel. The first thing is that I have a common factor of r minus 2. Remember, these two here are factors. They are being multiplied together to give me this. 6r squared times the quantity r minus 2. So they are factors. Okay, remember that. Over here I have factors. 4r is being multiplied by r minus 2. These are factors. And that would combine to give me 4r squared minus 8r. So I can cancel common factors. So I can cancel this with this, and that would give me a 1 and a 1. Now, in addition to that, I can do some more canceling. What I can do, 6 and 4 are each divisible by 2. If I divide this by 2, I get a 3. If I divide this by 2, I get a 2. Then I can also cancel one common factor of r. So this would be r to the first power, and this would just be a 1. So what I'd end up with, let me put equals here, I would have 3r. Everything else is a 1. It's times 1 and it's over 1. So then times, over here I'd have 1 over, I'd have 2, everything else is a 1. So essentially, when I write my answer here, this is going to be equal to 3r over 2. So just 3r over 2. All right, let's take a look at another one. So we have 1 over m minus 2, and this is divided by m minus 5 over m squared minus 10m plus 25. Okay, so the first thing I want to do is set this up. Remember, if I'm dividing, just like if I'm dividing with fractions, the first guy over here is going to stay the same. So 1 over m minus 2. Then I'm going to multiply by the reciprocal of this. So this is going to go in the numerator, m squared minus 10m plus 25. And then this is going to go in the denominator, m minus 5. Now, let's take a look at factoring the top. So we need two integers whose sum is negative 10 and whose product is 25. Well, negative 5 and negative 5 would be those two integers. So let's write equals 1 over m minus 2 times, I'm going to factor this into m minus 5 times m minus 5. And obviously I can cancel that with m minus 5 down here. And to make this obvious when you first start doing it, you can just write this as times 1, right? Anything times 1. So you can say this is a factor, and so is this. So it's 1 times that. All right, so we cancel common factors. Cancel this with this. And what I'm left with is 1 times m minus 5 in the numerator. Let me scroll down here. That would be m minus 5. And this is over m minus 2 times 1, which is just m minus 2. So my simplified answer here is m minus 5 over m minus 2. Okay, let's take a look at another one that's a little bit more tedious. So we have 4n over 2n squared minus 4n minus 6 times 10n squared plus 2n minus 8, and this is over 25n minus 20. So all I'm going to do is just factor everything completely, or as much as I need to figure out what's going to cancel. So, for example, in this numerator here, 4n, I'm not going to write 2 times n. I'm just going to write 4n. You can do that if you want, but I think it's a bit unnecessary. So then over, here you have 2n squared minus 4n minus 6. So I'm going to start by just pulling a 2 out of there. And that would give me n squared minus 2n minus 3. Now I can further factor this. So this would be n and then n. So give me two integers whose sum is negative 2 and whose product is negative 3. So that would be negative 3 and positive 1. So let me erase this part and I'll drag this up here. Okay, so then this is times. Up here I have 10n squared plus 2n minus 8. So let me factor that at the bottom because I need a little room for that. I'm just going to start by just putting, 2 times, if I pull a 2 out of there because it's common to everything, 5n squared plus n minus 4. Then over here, 25n minus 20, I can pull a 5 out, and that's going to give me 5n minus 4. Now, let me just factor this guy down here so I have a little room. 5n squared plus n minus 4. So 5n squared plus n minus 4. So I need two integers whose product is negative 20 for the product. And then I need a sum of 1. So for 20, forget about the negative for a minute. I know 5 times 4, so I can play with that and get a sum of 1. If I had positive 5 and negative 4, that would work out. So let's use those. So we would have, this is equal to 5n squared plus 5n minus 4n minus 4. If we factor this by grouping, I could pull a 5n out of the first group. That would leave me with an n plus 1 here. Out of the second group, I can pull out a negative 4. That would leave me with n plus 1 here. So the common binomial factor is n plus 1. So I would have 5n minus 4, that quantity, times n plus 1, that quantity. So that's your factored form. All right, so let's erase this real quick. We'll put that factored form in here. Nice and convenient. Okay, so now what we want to do is we want to look to see what we can cancel. We have everything that's factored as much as we need to. And so I see that I have a common factor of 5n minus 4. Again, this is multiplication here. Everything is being multiplied. This is multiplication. So these are all factors. So this factor of 5n minus 4 will cancel with this factor of 5n minus 4. This factor of n plus 1 will cancel with this factor of n plus 1. We can cancel this 2 with this 2. And is there anything left that I can cancel? There's nothing up here other than a 1. Remember, when your numerator or your denominator cancels completely, you write a 1. Down here, I just have a 5. So I need to be able to cancel a 5 with something over here. I can't, so that's simplified. Over here, I have a 4n and I have an n minus 3. Nothing else I can do. So when we multiply, 4n times 1 is 4n. This is over. We have the quantity n minus 3 times 5. So we just write that as 5 times the quantity n minus 3. Or you can leave it in this form, or you can write 4n over, use your distributive property, 5n minus 5 times 3 is 15. Okay, let's take a look at another one. So we have 2x squared minus 7x plus 5 over 2x minus 5. This is divided by 2x squared plus 11x plus 12 over 2x squared plus 13x plus 15. So for the first one, in the numerator, 2x squared minus 7x plus 5. Let's see if we can factor that. So I would need two integers whose product is 10 and whose sum is -7. So let me start by just writing 2x squared. So if I think about the factors of 10, it's really 2 and 5. If I did -5 and -2, that would work. So I would do minus 2x, then minus 5x, then plus 5. If I want to factor this by grouping, I'd pull out a 2x from the first group, and I would have x minus 1. From the second group, I would pull out a -5, so minus 5, and that would give me an x minus 1. And so if I pulled out the common binomial factor of x minus 1, I would have 2x minus 5 times x minus 1. All right, so let's erase all this. And we'll kind of drag this up to the top. So we'll put equals, and we'll drag this up. Okay, so this is over 2x minus 5. So we can cancel that right away if we want, or we can just kind of wait till we're done and we cancel everything at once. So that's what I'm going to do. Now we're dividing by this guy right here. So let's just start by finding the reciprocal. We're going to put multiplied by, I'm going to take the denominator here and put it in the numerator, 2x squared plus 13x plus 15. And then over the numerator, we're going to the denominator, 2x squared plus 11x plus 12. Okay, so let's factor each one separately here. So if I had 2x squared plus 13x plus 15. So two integers whose product is 30 and whose sum is 13. So for 30, I've got 1 times 30. I've got 2 times 15. Can I play with the signs there? No, because everything is positive, right? So I can't really use that. I've got 3 times 10, and that would work if I did positive 3 and positive 10. So let's go with that. So then this equals 2x squared plus 10x plus 3x plus 15. And again, we're going to factor by grouping. So from the first group, I'm going to pull out a 2x. That would leave me with an x plus 5. From the second group, I'll pull out a 3. That'll leave me with x plus 5. And so pull out the common binomial factor of x plus 5, and you would get 2x plus 3, that quantity, times x plus 5, that quantity. So let's copy this. All right, let's also look at 2x squared plus 11x plus 12. So 2x squared plus 11x plus 12. So for this right here, let's think about two integers whose product is 24 and whose sum is 11. So for 24, I can do 1 times 24. I can do 2 times 12. I can do 3 times 8. So 3 and 8 would work. So let's break this up. We'll say this equals 2x squared plus 8x plus 3x plus 12. So in the first group, I can pull out a 2x. So let's pull out 2x. And inside, I would have what? I would have x plus 4. In the second group, I can pull out a 3. So what I'd have left is, again, x plus 4. So the common binomial factor here is x plus 4. So let's go ahead and pull that guy out, and I have 2x plus 3 times x plus 4. So this is 2x plus 3 times x plus 4. So now that we've factored everything, I know that's the kind of tedious, boring part, but once you've gotten through that, the rest of it's pretty simple. I'm just going to look for common factors and cancel. Remember, everything is being multiplied. So these are common factors. So I can put this as times 1 here, and I can cancel 2x minus 5, that factor with 2x minus 5 up here. And then I don't have any x minus 1s anywhere else, so I can't do anything with that. But I can cancel this factor of 2x plus 3 with this factor of 2x plus 3. And what I'm left with is x minus 1. So x minus 1, then times x plus 5 over 1 times x plus 4. So basically x plus 4. Now, you can leave it in this format if you want, or your teacher might want you to use FOIL and present this as a trinomial in the top. That's fine. Either way, it's the same thing. So x times x is x squared. The outer would be 5x. The inner would be minus x, so this is plus 4x. And then the final, or the last, would be negative 1 times 5, which is minus 5. And again, this is over x plus 4. So you get x squared plus 4x minus 5 over x plus 4. All right, let's take a look at one final problem. So I have 2n squared minus 4n minus 6. This is over 35n squared plus 8n minus 16. This is divided by 2n squared plus 18n plus 16 over 5n plus 4. So I want to just factor everything here and see what's going to cancel. So if I start out in the numerator, I have 2n squared minus 4n minus 6. And in this particular case, we've already factored this in a previous problem. So I'd pull a 2 out to start. And what I'd have is I'd have n squared minus 2n minus 3. So give me two integers whose product is negative 3 and whose sum is negative 2. Well, that would be negative 3 and positive 1. So I would have n minus 3, and then n plus 1. And a lot of you will remember that again from a previous problem. So this is going to be over. I need to factor that down here because I'm going to need a little room to do that. So let's kind of scroll down a little bit. So 35n squared plus 8n minus 16. So if I multiply 35 times negative 16, I would get negative 560. And that's what I'm looking for as far as the product. For my sum, I want 8. Now, most of us do not work with 560 a lot. So this is something to where you want to make a factor tree and kind of think about what the prime factorization is. So I would just start with something like, 10 times 56. Okay, nice and simple. So that's obviously not close for me. So then 10 is 5 times 2. 56, if I did 28 times 2. Now I want you to notice something here. If I have 28 times 20, 28 and 20, I can make that work. So I could stop here. For the sake of the factor tree, let's just continue. This is 4 times 7, and then 4 is 2 times 2. So let me kind of erase this now. We have our two integers. So we know it's 20 and 28. What do the signs need to be? Well, since the sum is positive, I want the larger absolute value to be positive. So I want to do positive 28 and negative 20. So then let's erase this real quick. Let's say, okay, we have 35n squared plus 28n minus 20n and then minus 16. Okay, so in the first group, I could pull out a 7n. So this would be 7n. And what would be left is 5n plus a 4. In the second group, I can pull out a negative 4. And what would be left would be 5n plus 4. So if I factor out the common binomial factor of 5n plus 4, I would have 7n minus 4 times 5n plus 4. So let's go ahead and copy this. Okay, we're going to paste this right here. Okay, now the rest of this is pretty simple. Now we're dividing by, so I'm going to put a multiplication sign here. And then I'm going to take the reciprocal of this. So the 5n plus 4 is going to go up top. In the denominator here, I can factor out a 2 before I start. So that's going to make things simpler. And I'd have n squared plus 9n plus 8. Now give me two integers whose sum is 9 and whose product is 8. Well, that would just be 8 and 1. So we would do n plus 8. And then n plus 1. Now, I've got this as factored as I can get it. All I want to do now is look to see what I can cancel. So I can cancel a common factor of n plus 1. I can cancel a common factor of 5n plus 4. Remember, I could write this as times 1. So this would cancel with this. And then anything else I can cancel this 2 with this 2. And what I'm looking at, in my numerator, I'm going to have an n minus 3. In my denominator, I'll have this quantity 7n minus 4 times this quantity n plus 8. Now again, in a lot of cases, you can just write this and stop. Your teacher might not want you to, kind of come down here in the denominator and do FOIL, but she might want you to do it. It doesn't matter. It's the same thing either way. So if she asks for it, do it. If not, you can just stop. So this is n minus 3 over 7n times n is 7n squared. The outer would be positive 56n. The inner would be negative 4n, so this would be plus 52n. And then the last, negative 4 times 8 is negative 32. So you get n minus 3 over 7n squared plus 52n minus 32.